Hello everyone, it's Mr. Tinker here, and I'm here to go over the lesson with you of 2.9 Weighted Averages. Now at this moment, you should pull out your notes. This is going to be really important that you write down some of this stuff for practice, for muscle memory, and for some of the example problems that are in here. They may be multiple choice, but you should be working them out and not relying on me. After all, there are going to be questions that you have to answer before you see the right answer. So with that, make sure that you're looking over this, that you're understanding each section. As you watch the video, it'll keep going on, but you'll be able to jump back at the click of a button. You just can't move forward unless you've watched up to that point. Okay? The last thing you should do is also write down any questions you have. Any questions you have should be asked on Monday, because Monday we can answer them right before the test, go over a bunch of example problems, do a nice big practice test, get the answers for that, and have a good night's rest so that way we can study and have a good night's rest. So that way you're ready for the test on Tuesday. Alright, we good? Here we go. Here are the different standards that are covered in this lesson. Forget it. We're going to move forward. We got two objectives today. Two of them. Solve mixture problems and solve uniform motion problems. They're pretty similar in a way. There is one difference that we will have to go over, one different type of problem from the rest, but the others follow the same type of pattern. Alright, so first let's look into this. A mixture problem, or mixture problems, are problems where two or more parts are combined in a whole. I'm going to keep going for the sake of the video. If you need to write this down, pause the video here and write stuff down. I'm going to continue. The weighted average of a set of data is the sum of the product of each number in the set and its weight divided by the sum of all weights. Now, this may seem like a very confusing definition. Weighted average? What is this? What on earth does this mean? Well, let's look at an example. Let's say Sarah is rolling a dice by 50 times. Each die has 6 faces with a different number on it. Like 1, 3, 5. So it's 1 through 6. If she rolls, she gets these different examples. She gets 1, 9 times. She gets 2, 8 times. She gets 3, 6 times. She gets 4, 11 times. She gets 5, 10 times. And she gets 6, 6 times. We can chart this. This will look much nicer this way, here in a chart, where the top numbers represent the number on the dice. When she rolls, what number was it? 1 through 6. And this is how many times each one was rolled. Alright? So, what if we wanted to know what the average value of her rolls are? Right? What number is she most likely to get? Well, the way we would do that is we would take each of these values on the dice, each dice value, and multiply it by the number of rolls it got. So we would do 1 times 9, and 2 times 8, and 3 times 6, and 4 times 11. Then we want to add all of these together and divide by the total number of rolls, the 50. So that looks like this. We have 1 times 9, plus 2 times 8, plus 3 times 6, plus 4 times 11, plus 5 times 10, plus 6 times 6, all divided by 50, because that's the number of rolls. So we've taken each value, like 1, 2, 3, 4, and multiplied it by its weight, the amount of times it shows up, 9, 8, 6, divided by the total number of rolls, and this gives us an average of 3.46. So she is likely to roll somewhere between 3 and 4 most often, okay, based upon her data. Okay, now with that out of the way, we're going to be using this concept in a very different way. Let's start with a mixture problem. So, we have this girl Mendisha. She is feeding her cat gourmet food. Gourmet is like expensive, high-end food, like the best. Like if you're thinking about beef, there are different types of beef, and filet mignon is one of the top cuts of beef. Very expensive, costs a lot. So this gourmet cat food costs $1.75 per pound. Every pound of cat food costs $1.75 here. She then combines it with cheaper food that costs 50 cents per pound. 50 cents per pound. So that's a lot less. How many pounds of cheap food should Mandisha buy to go with the 5 pounds of gourmet food that she buys? If she wants the average price to be about $1 per pound. So she's not skimping out on her cat too much. She wants to use cheap cat food with gourmet cat food, mix it together so that way it makes a nicer price, but not as cheap as the cheap cat food. Does that make sense? Okay, so the first thing we need to look at are some big ideas. Big idea number one, the price per pound. Okay, price per pound times the number of pounds will give us price, or if we look at it in symbols, dollars over pounds times pounds will give us dollars. This is just like a conversion problem. The second big idea is the sum of the gourmet cat food and the cheap cat food price is equal to the price of the mixture. So that looks like this. Gourmet price plus cheap price equals mixed price. So now we need to start listing a bunch of these things. So let's move on. Let's make a table. First, we're going to say that we're going to make a variable for what we want to know. The number of pounds of the cheap cat food, right? That's going to be our variable. The number of pounds for the cheap cat food. Now we're going to make a table. So here we are. We have a table. We have a lot of things to list. So let's think about this. We have 3 different types of things for cat food. We have gourmet cat food. We have cheap cat food. And we have the mixed cat food, the mixture of it all. Does that make sense so far? We're mixing it up. We're putting a little of this and putting a little of this, and we're mixing it together. Mixing cat food. Then, we need to look at the units. How much of it are we buying? We also need to look at the price per pound. The price for each pound of food here, cat food. And lastly, we're looking at the total price. Okay, move my picture out of the way here. We're looking at the total price here. So let's start answering these. Gourmet cat food. How many is she buying? 5 pounds. It says so in the problem. Price per unit? $1.75 per pound. Total price? Let's multiply them. Pounds times price per pound? That's going to be $8.75 for the whole thing. Let's look at the cheap cat food. Do we know how much? Nope, that's our variable, W here. But we do know the price per pound. The price for each pound of cheap cat food is 50 cents. So now we have that. So we multiply that together and we have 0.5 W for the price of the cheap cat food. Next, we are taking the mixed cat food. This is the crazy part. So the mixed cat food is the combined total of these things. So that means we're going to take 5 plus W to get the mixed cat food. For the price per unit, this time we're not adding. This time we're told that we want it to be around $1 for every pound. $1 for every pound. We're told this price. That's excellent. So we can just fill that in. $1 per pound. And the total price, well, the amount of pounds times the price per pound that we want it at is multiplying it together. Alright. Now this is where it gets awesome. Going back, we had just said on the previous slide, if you need to go back look, that the price of the gourmet cat food plus the price of the cheap cat food is the total price of the mixed cat food. They should be the same. This plus this equals this. Let's set that up. So price of gourmet cat food plus price of cheaper cat food equals price of mixed cat food. It looks like this. And the rest is an equation that you can solve. You simplify. You move W over. I'm going to subtract 0.5 W from both sides. And that'll give me 8.75 equals 5 plus 0.5 W. If you need time to digest this, pause the video right now, but I'm going to continue. Then I'm going to subtract 5 from both sides, so that way that leaves me with 3.75 equals 0.5 W. Divide by 0.5 to both sides, and we find W equals 7.5, giving us the grand answer that Mandisha should buy 7.5 pounds of the cheap cat food. Hopefully you're feeling really good. Okay, so now we're going to move on to an example. So I'm going to let you read this and let you answer this in just a minute, but first I want to get you on track. So we have ounces of seed beads. That's our big thing that we're looking at right now. Together we need the price of the glass beads plus the price of the seed beads to equal the price of the whole project. So far, we know that the price of the glass beads are $1.79 and she bought 3 ounces. We know the price of the seed beads are 0.99 B, right, 99 cents times the number of ounces of beads. And the price of the project, she wanted the average price to be $1.29, and that's multiplied by the number of ounces, 3 plus B. Okay, so we have this right now. So I want you to try and solve this. See if you can use the equation given to you right here, and using the information I've outlined for you right now, let's see if you can figure out the answer. And we're back. So you should have seen that we can replace everything within that setup equation and solve for B, giving us 5 ounces as our answer. Hopefully you got that. Now let's move on to a percent mixture problem. This works almost exactly the same way, but there's a difference. A car's radiator has a solution of 50% antifreeze, as we see right here. So we want the car to have 50% antifreeze. But Bay, his has 2 gallons of 35% antifreeze. That's not enough. He needs to raise it. So he pours in pure antifreeze, 100% antifreeze. How much does he need to add to make it a 50% solution? Let's find out. Let's mix it up. So we're going to do like we did on the last problem. Let's make a table. So G is going to represent the gallons of pure antifreeze, 100% antifreeze. So we have 3 categories of antifreeze. We have 35%, 100%, sorry, and 50%. Then we're going to look at the amount of gallons that they need to add and the amount of antifreeze, which will be created by the percent of the solution times the amount of gallons. So we are told that he has got 2 gallons of 35% antifreeze. So we are going to multiply 0.35, 35%, times 2. Same thing with 100%. We don't know how many gallons, but we'll multiply 100% by G. So that's 1 times G. And for the 50% solution, we note that it's a mixture of 2 gallons plus how many gallons we're adding. That's 2 plus G. And that's going to be multiplied by the 50%. So we get 0.5 times 2 plus G. The rest is the same that we've been working with. So we're going to take these sums and add them together. We have the 35% antifreeze plus the 100% antifreeze makes the 50% solution. And we have all these weighted averages, or all these averages adding together. So here we go. We put them together, we simplify, and then I'm going to subtract 0.5G from both sides. This should give us 0.7 equals 0.5G equals 1. Continue solving. Pause it if you need to. Subtract 0.7 from both sides. And now we have 0.5G equals 0.3. Divide, and we get 0.6. So 0.6 gallons, that is our answer. 0.6 gallons of 100% antifreeze should be added to that mixture to achieve the right percentage. Now, if you need to review this problem, we're moving ahead to a practice problem. So here we got a bunch of peanuts. We have 50% peanuts, we've got half a pound of 15% peanuts, and we have 75%, we're going to add 75% peanuts. How many pounds do we need to make 50%? Okay, so again, I'm going to help you with the setup. First we need P pounds, right? P representing the pounds of the 75 peanuts, or 75% peanuts. Then we're having the amount of the 15% peanuts plus the amount of the 75% peanuts, making a half mixture, 50% peanuts. So we can calculate our 15% peanuts, we can calculate our 75% peanuts, and our 50% peanuts, based upon the percentage and the weight that we want to multiply together. I'm going to pause the video here, and you're going to answer. And we're back. Hopefully you were able to solve this out by replacing each of this information into the equation and solve for the answer of D. We'll be back in just a minute for another episode.